Welcome to Third Eye Weekly. Joining us today is Steve Croft. He's an assistant project astronomer at the Department of Astronomy at UC Berkeley. Thanks for joining us today.
Thanks for the invitation.
Absolutely. So tell us a little bit about how you became involved with Berkeley's SCTI Center.
Yeah, so the SETI group here at Berkeley has a reasonably long history. About 15 years ago, the SETI at Home screensaver came out, and this was an idea of combining together individual computers that people had at home and using the sort of spare computing power that they had to comb through the vast amounts of data that we're getting from the current generation of radio telescopes. My background as a radio astronomer, I've been at Berkeley since 2007, is really kind of looking at the environments of supermassive black holes that live at the centers of galaxies and the radio emission that comes from these natural phenomena. But some of the techniques that we're using in radio astronomy are very similar to the techniques that are being used by SETI researchers. So I sort of got involved with the SETI group, I guess, about a year ago. The SETI group here is expanding, and the techniques that they're using with these radio telescopes to search for signs of intelligent civilizations beyond Earth are similar to the techniques that are used in sort of more classical radio astronomy.
Tell us a little bit about the study of radio galaxies that you do in particular. So is it, how is their relationship with black holes in that, and does it at all work with the research you do at SETI?
Yeah, so a lot of people think of black holes as being things that just suck everything in, and you're never going to see one, but they actually betray their presence, particularly when they're snacking on things that are going past. They might snack on a star occasionally, or they might kind of be constantly feeding on surrounding gas, and they're sort of messy eaters. And so you see emission actually all across the electromagnetic spectrum, from X-rays and gamma rays at one end through kind of optical light that our eyes are sensitive to, and out to radio wavelengths at the other end of the spectrum. And so we're sort of seeing material that is churning up around these black holes. We see jets that are flying out from the regions nearby them at close to the speed of light. And there are electrons that are spiraling around in really strong magnetic fields, which give rise to these radio waves that we can pick up with big telescopes. And there's actually a move now towards building sort of the next generation of radio telescopes. There are several new facilities that are coming online that are really going to be very powerful. Essentially, they've been described as like IMAX cameras looking up at the sky, operating at radio wavelengths. So you see a very large region of the sky, and you can keep on going back sort of very regularly and look for things that change. And that's sort of one of the techniques that we're using, again, for probing the emission near these supermassive black holes and other objects like exploding stars known as supernovae, gamma ray bursts. There are all sorts of things that kind of go bump in the night in the radio sky. But one of those things as well that we're looking for in terms of this kind of transient emission is possibly artificial signals, scanning the skies to see if there's anything else out there that can't be explained in terms of those natural phenomena.
I remember reading that these black hole emissions in these radio galaxies, in some way, we might be able to use them as a kind of time machine. I was wondering if you could talk a little bit about that.
Yeah, maybe what you're sort of referring to is the fact that it takes light a while to reach us from these distant objects in space. So, the sun is a few light minutes away. If the sun disappeared, we wouldn't know about it for a few minutes. That's how long it would take the light to reach us. I'm sure with the movie The Martian coming out, probably many of your viewers are going to go see that movie or have read the book. And one of the sort of central plot features in that book is the time that it takes for communication between Mars and Earth. Even traveling at the speed of light, it takes a while to get those signals back and forth. And so when we're looking at galaxies that are much further away, and actually even our nearest neighbor galaxy, the Andromeda Galaxy, the nearest large neighbor to the Milky Way, is 2 million light years away, you're actually seeing the light as it left that galaxy 2 million years ago. I was actually out at my in-laws' house in Colorado last weekend. Many of your listeners probably as well were out looking at the blood moon, the lunar eclipse there. And I got a photograph. I set my camera up on their deck and got a photograph of the moon, and also realized afterwards I'd caught the Andromeda Galaxy in this picture as well. It's actually pretty bright and it's pretty big on the sky. And if you know where to look, if you're out in a dark sky site, then you can see the Andromeda Galaxy. It's a couple of times bigger than the full moon on the sky. It's just kind of faint. It looks like a faint smudge. And it's kind of cool to think that the photons, the light that's hitting your eye as you're looking at the Andromeda Galaxy, left that galaxy 2 million years ago when humans were sort of just getting started, basically, on the plains in Africa. And it's been traveling all that time to reach us. And that's a nearby galaxy. So we can look at galaxies that are billions of light years away and see how they were in the past when the universe was just a fraction of its current age. And so that's really, this isn't sort of on the SETI side of things. The SETI targets are a lot closer. They tend to be stars in our own galaxy that are much nearer to Earth, maybe sort of tens or hundreds of light years away. Still would pose a problem for communication if you're trying to sort of have a back and forth with them. If you wanted to interview ET on your radio show, then the conversation is going to be pretty stilted. But there are these sort of time travel aspects to some of what we do. We're not actually traveling back in time, but we get these signals that are telling us how things were some time ago in the past.
So some of the new equipment that you guys are getting at the SETI Center, is that from the recent investment that's being made into the center from Yuri Milner? Is that right? An internet investor that committed about $100 million over 10 years to UCP?
Yeah, that's right. I mean, that's been a massive vote of confidence in the SETI project. The sort of move in the field of radio astronomy towards these new instruments is something that's been happening for a little while. The international astronomy community is moving towards an instrument called the Square Kilometre Array, which is going to be based in Western Australia and in South Africa, actually in Southern Africa. It's going to be a big sort of multi-antenna telescope that's spread out over a large area. And the SKA is going to be sort of transformational for a lot of fields of radio astronomy with amazing sensitivity and really big collecting area, amazing resolution and frequency capabilities, really sort of scanning new areas of sort of the space that we're exploring in order to find signals. And so everyone's sort of gearing up towards this. There's, as I say, a lot of astronomers that are really interested, but SETI has always been kind of the sort of little fish in a big pond, I guess. At some level, we've been kind of scraping by on kind of borrowing time on other people's telescopes and on kind of little bits and pieces here and there where we can get a hold of them. And so this influx of money from Breakthrough, from Yuri Milner's initiative, is really going to help us expand the telescopes that we're on, expand the amount of time, the instruments that we're using, and also, I think most importantly, actually expand the number of people working on this. There's probably only a couple of dozen sort of professional researchers in SETI across the world. And we really need sort of fresh blood to come in and people to look through the huge amounts of data that we're going to be getting from the new telescopes.
Right?
Yeah. Speaking to those huge swaths of data, these newly VAN programs, like you said, are going to be collecting some of the largest amounts of scientific data ever made public. How are you guys going to translate this new flux of data to the public?
Yeah, I mean, that's a big question, and there's sort of a commitment that's been made as part of this that we're going to try and be sort of as open as we can in terms of getting the data out. Now, obviously, as I mentioned earlier, Berkeley has a history with sort of public engagement with the data, with citizen scientists, people who are running the screensaver, the SETI at Home screensaver on their home computers. And so we anticipate that it will continue to be sort of a part of that, where at least kind of some of the data is going to be going out, and we're going to need sort of help from the community in processing that. But we're also going to have to come up with new techniques. We're helped by the fact that Moore's law, basically the expansion in the power of computers as time goes by, means that we can process more and more data just by kind of upgrading our computers to the latest generation. But it's still, the data handling thing is a huge challenge, and we're fortunate here at Berkeley that we have, first of all, there's a group called the Collaboration for Astronomy Signal Processing and Electronics Research, or CASPER, and it's sort of an open source approach that is actually using GPU cards, which if you play video games, these are the cards that kind of render your video games, and they also turn out to be pretty good at processing large amounts of data in parallel. And so the CASPER group is developing techniques for these GPUs that will enable them to sort of handle really huge data rates that we're expecting from the new telescopes too.
So with this new influx of money and these new advanced technologies, how confident are you and people at the SETI Center in finding extraterrestrial life with these new technologies? Yeah,
I mean, that's the sort of $100 million question, I guess, at some level that we're trying to answer. One thing that's happened in the last kind of 20 or 30 years, and again, there's been a lot of involvement at Berkeley with this, with people like Jeff Marcy, who is also involved in the NEO initiative, has been the search for planets around other stars. And maybe 30 or 40 years ago, we really didn't know how common planets were at all. And we now are realizing, with the results from the Kepler telescope and with results from telescopes that are operated by the University of California, including ones up at Lick Observatory, where Jeff Marcy has done a lot of his work. The planets are pretty common around other stars. There's probably something like an average of one Earth-like planet per star in our galaxy. And when you think that there are hundreds of billions of stars in the galaxy, it's hundreds of billions of planets. And so the question then, in our minds is, well, are any of those inhabited? Are none of them inhabited? And we have no clue at this stage. We just have to do the search. We have to go out there and expand the search that we're doing. And maybe the answer will be, well, as far as we know, there are fewer than some upper limit number of technological civilizations that are transmitting in the radio right now in our galaxy. But the alternative scenario is that within sort of the next decade, we actually detect a signal. And I think, it's exciting to do the search, even if the answer is that, you keep on coming up with a negative result at some level, because, either we're very special in human terms, in that, the Earth is one of the very few places in the universe where intelligent life arose, or intelligent life is common. And, there's a potential of sort of learning from both answers to that question.
So do you think this new technology and data could help inspire maybe government officials to help change their perspective in funding SETI programs in the future?
It's interesting that you mentioned that, because actually our director, Dr. Andrew Simeon, was called to testify along with several other experts in Congress earlier this week in front of the House Science and Technology Committee. And there's video of it available online. It's a pretty interesting conversation. I mean, you can see these House members who, most of them seem to be pretty fascinated to be there. And I think it was sort of, a way to get away from sort of some of the humdrum stuff with the government shutdown and all this kind of stuff looming. They got to just talk about science and to talk about exploration and to talk about inspiring a new generation of high school students to get involved in science and technology careers. And so, I think there is interest there. As I mentioned, SETI has not done terribly well in terms of getting government funding over the last couple of decades. I think in part because, although there's a great deal of interest, perhaps there's also this kind of giggle factor where it will be an easy target for political opponents to say, oh, this guy, sponsored this initiative to find little green men, and people think of, tinfoil hats and kind of crazy people out in the field sort of looking at bright lights in the sky through their kind of homemade equipment, dialing things in. And we're really trying to sort of, be a little bit more legitimate than that. And I think, we are, we're sort of doing a good job of kind of communicating our science and the reason why we want to do this. But as yet, I think it's sort of still a work in progress to persuade government to really kind of jump back in and sort of support this in a bigger way. But we're really, we're very pleased to have support from people like the Breakthrough Initiatives. We've also had some support from the John Templeton Foundation and others that's enabled us to kind of keep SETI going over the last few years. So yeah, it's sort of bright times ahead, I think.
Great. Well, we'll be sure to check that out. I'd like to see Congress in reaction to somebody from SETI Center convincing them to donate more for extraterrestrial life. That's interesting.
Yeah.
Well, that's all the questions we have today, though. Thank you so much.
Okay. Yeah. Thanks for the opportunity.
Thanks, Steve.
All right. We'll send you a link to